Okay, this video segment is done because of the question that was raised by one of my subscribers, Paulo in Brazil. The question that he asked me was this statement. Now, I could not exactly know what he had in mind, but I have an idea that it may be that the kind of question that he's asking is this. Suppose you have an assembly made of different parts, and what you want to do is you want to place a spring element between two nodes of this assembly and do something with it. Now, the answer to this question is yes and no, because it is not possible to just place a spring between two nodes uh, in a straightforward way. Okay. However, uh, if care is taken, one can actually do that. So I decided to do this example where I have a block. Blocks are shown here made out of steel, and there are uh, uh, two eventually nodes. For example, the midpoint of this top face and the midpoint of the bottom face of that. And I want to place a spring between these two nodes. So, and I'll come back to that in a second. The face A, B, C, D is clamped, and all these peripheral faces of the top and the bottom block or surface slider or rollers, and then a pressure is applied to the top face so that it push this thing up and make the spring stretch. Now, uh, in general, if you made a mesh for the top block and the bottom block, and then you try to select a node here and a node there, you won't be able to do that because nodes are not readily accessible in the Catia program. However, if you follow the instructions that is given in this program and you want to make sure then you're going to make sure that the nodes at these two locations are actually accessible. Okay. By the way, this is made out of steel. What I did for the properties of these things, I made the stiffness of this 1,000 pounds per inch. And if you do a simple calculation, you see that the stiffness of the top and the bottom block in the axial direction is a lot bigger than that. So basically, the top and the bottom block actually stay rigid as pretty much as undeformed. Okay, they're not rigid object, but they're very stiff, and therefore they just make the spring stretch. Now, if you do a simple calculation here, uh, uh, because these are assumed to be so stiff or will be so stiff that they're basically treated as rigid, is that if you put 1,000 pound force on that face, that pressure is equivalent to 1,000 pound force on that face on this spring, which has a stiffness of 1,000 pound per inch. You see that this will actually stretch by 1 inch. Okay, we're assuming all linear stuff here, so maybe it doesn't make sense, but it's linear, so we want to see whether this process works or not. Okay, so here's what we're going to do. Let me create those two blocks for you. I have an assembly here, so insert a first part, new part in there. This is going to be the bottom block, so let me go ahead and make it. On that plane, I will sketch a square 1 by 1, 1 inch by 1 inch there. Let me put some dimensions here. This is going to be 1 inch and 1 inch here. Let me change that thing to 1. Oh no, this is a very straightforward construction that I'm going to do, but anyway, I would like to start from the very beginning. So exit and pad it by 1 inch. Where's the pad here? Right here, pad by 1 inch. And I'm going to create a point on this plane, the midpoint of that plane. So a point on this face is coordinate 0, 0, 0. So not 0, 0, 0. This local coordinate 0 and 0. Okay. Uh, there, you can see that the point has been created here. Okay, very good. Now let's insert the second part. Insert, new part. This is going to be the top one. Say no, let's go and make it. I mean, obviously you can use this thing, save it and use this thing as an instance, but that's okay. So I'm going to make a plane. I'm going to make a plane 1 inch away from that top face. And on that plane, I will sketch a square 1 by 1 again. Let me mention this. This approach that I'm going to show you is not the only way of solving this problem, but that's what came to my mind, assuming that I'm interpreting Paulo's question correctly. And then pad it by 1 inch. Okay, in the other direction. Flip the direction. Okay, good. And then I want to point at the bottom face, on this face, point on this, coordinate 0, 0, 0. Okay, good. Point is created. Very good. So let me go ahead and make this thing entirely out of steel. So metal, apply material, metal, steel on that entire assembly. So every part is going to be made out of steel. And by the way, if you look at the properties of steel, the Young's modulus is 29 million, almost 29 million psi, right there, that number. And this is why in my calculation I use that number. Okay, good. And now this is pretty much done. So now we're going to mesh this assembly. So we're going to go to now. Let's go to Advanced Meshing Tool. Advanced Meshing Tool. See that? Advanced Meshing Tool. I'm not going to go to generative structure analysis. You see why? Advanced Meshing Tool. It's a static problem, and I'm going to use a quad octahedral elements. Let's do the bottom one. So I'm going to mesh this. Now, there is a tab here which says local. By the way, notice that I'm using parabolic, okay? It really doesn't matter, so I can use linear. It makes no difference. Local, impose point. See that? Impose point here. Add. And I'm going to select this point that I created there. So this makes sure that there is a node there in the middle, which is going to be accessible to create that spring element later on. So we say, okay. And we do the same thing for the top one. This one. Once again, I use element, a linear element, so local, impose point, add, and now I'm going to use this point here. It's guaranteed that there's going to be a node there, which is going to be accessible to create our spring element later on. Okay, very good. That's pretty much it. So now we're going to go to generative structure analysis. And let's actually create the 3D property here because it doesn't have it, made out of steel. Okay, very good. Do the same thing for the top one. Excellent. All right. Now I want to create that spring element. The question is, how am I going to do that? So let's go ahead to the analysis connection. Right there, see that? Analysis correction. First, create a connection between this point and that point. Okay? Now, I'm not talking about nodes. I'm talking about the points because there's going to be a node sitting there for sure. So this point as the first component. For the second point, that point over there, right there. Okay, and this particular connection that we just created, we're going to make it go to connection properties right there. See that? Connection property. And we want a user defined connection property. Okay? User defined. Now, the type that we want is to rigid spring rigid. Okay? So let me click on the wrench here. Let me actually do the following second. For support, for the support, I select this connection that I created. See that? For the support, I select this connection that I created, and automatically it becomes rigid spring rigid. Of course, you can choose other things, but that's what we want: rigid spring rigid. Click on the wrench, and for the stiffness in the direction 3, direction Z, put your thousand pound per inch. Okay, 1,000 pound per inch, right there, 1,000 pound per inch. I already had it here, so right there. So we say okay, and we say okay. All right. So now we're going to clamp the bottom. Once again, I want to remind you this is not the only way of doing your problem. There are other ways. So be my guest, trying other approaches. And all these side faces are going to be clamped. Not clamped, roller, surface slider. This will give you an idea, assuming that I understand Paulo's question correctly, will give you an idea of what to do with your own problem, or he can figure it out. Say okay. And finally, there is a pressure there, pressure on the top. So pressure of 1,000, right there. Negative 1,000, that means outward. See that? Outward, upward. Say okay. And I think that's pretty much it. So, yep, let's run it. Don't worry about this message. Say yes. That's a warning message. That's okay. Done. So if I look at the displacement, here's the displacement. See that? I will get 1 inch. If you animate it, you can see what happens is that this block moves up 1 inch, which means that it's going to stretch that spring by 1 inch. Now, if you want to see it better, let me do the following. Close that. Double click on this contour. Just say, just show me the spring, which is here, generic connection mesh 1. Don't show me all the stuff. Now, if you say okay, anything that you don't like, you can hide. This stuff I can hide. That stuff I can hide. Same thing here. I'll leave the clamp there so that you have an idea of what's happening, and you can animate it. See that? This spring stretches by 1 inch. That means it gave me the correct value. Anyway, the idea was to show you how to create a spring element between two nodes of an assembly. In general, unless you have a point there, you can't do it. So what I did, I created a point, made sure that at the locations that I wanted, 2 points, made sure that when I meshed it, those 2 points are included in the mesh, and then created a general analysis connection between those 2 points and made a user-defined connection property, rigid spring rigid. Okay, and it gives me what I want. I hope I've answered your question, Paulo.